One of the most impactful learning moments for me was taking a workshop at MIT in 2014, which ended up tremendously influencing my thinking. I took the class because it was taught by Dr. Steven Spear, who I mentioned earlier today in my opening remarks. He is famous for many things, but he's probably most famous for writing one of the most downloaded Harvard Business Review papers of all time. In 1999, he wrote a paper called Decoding the DNA of the Toyota Production System. This was based in part on his PhD dissertation that he did at the Harvard Business School, and in support of that, he worked on the manufacturing plant floor of a Tier 1 Toyota supplier for 6 months. Since then, he's extended his work beyond just high repetition manufacturing work to engine design at Pratt & Whitney, to building a safety culture at Alcoa, helping make safe healthcare systems. He was also part of a US Navy initiative to create high-velocity learning across all aspects of the enterprise. He spoke at the conference in 2015. He was a part of the panel with Dr. Richard Cook and Dr. Sidney Decker from the safety community. And I shared with you my belief that what will replace the current modes of management thinking is dynamic learning organizations. And that belief really comes from Dr. Steven Spear's work. So with no further ado, I'm hoping you will believe the same thing. Thank you.
All right. How y'all doing? All right. So, Gene, thank you for the nice introduction. Behind, he said, Steve, you got to keep it to 30 minutes because people have to finish up and get drinks before the next piece. I said, Gene, the Sox and the Dodgers in the middle of the first with Mookie Betts on second. I mean, if I last 10 minutes, I'm happy. So drinks may be early. Anyway, so let me cut to the chase here. I'm going to make a case for 3 key points. First, learning is good. Not surprising, a guy coming from MIT wearing a bow tie and glasses. But what I mean more particularly is that knowing how to get smarter, better, faster matters a lot. And I'll give some examples of just the profound differences between those who learn very, very well and those who learn in a more normal fashion. Second point is learning's fairly easy. All it requires is that you aggressively seek out fault. I grew up in New York, the same neighborhood the Trump family is from. You can see it's a natural thing where we come from. You know, no matter what you're doing, hey, that sucks, that's awful, it's terrible. But it turns out that finding fault is a necessary trigger and the first informer that you don't understand and that you need to do something differently. So we'll build on that in some examples. And then, of course, that leads to the third critical point, that easy to say and hard to do in terms of this whole finding fault in your thinking, finding fault in your doing, and correcting on it. So anyway, let me take that first point. Gene mentioned that my roots are trying to understand why Toyota had such a hugely dominant presence, still does actually, in its sector. So just to sort of quantify what that difference looks like. So Toyota came to the US market in the late 1950s, and they showed up with a car called the Toyopet. Now, you are the guys I can see. Anyone ever hear of a Toyopet? Like 1 or 2 of you, right? What does that tell you about a Toyopet? Because you've heard of a Model T, you've heard of a Lamborghini, Chevy Corvette. So if 1 in a few hundred heard of a Toyopet, it suggests, you said it. It sucked, right? He said it, not me. I'm just quoting, right? Yeah, it's his vulgarity. I'm just, reporting accurately. So let's add some dimensionality to the word suck. So the Toyopet, when it came to the United States, if you had to drive up a hill, the odds, again, no guarantee you'd get to the top of the hill, but if you wanted to increase the odds, it was better if you were in reverse. First market for the Toyopet was California. So I'm willing to bet that there's some hills either east of Los Angeles or by San Francisco. If you go by and you see like a rotten pile of metal all covered in rust, that well may be a Toyopet. All right, so let's take this through. So Toyota starts off with this abysmal product called the Toyopet. Turns out they were abysmal at making an abysmal product. Toyota's productivity in 1957-58 was about 1/8 the world standard, which I guess is good, because if they were as good as everybody else, they would have made a lot more Toyopets. But here's the thing. From 1957 You can imagine they left the US market then. Until 1962, Toyota went from 1/8 the world standard in terms of productivity to equal the world standard. By the late 1960s, their productivity was double the world standard. Now, Toyota comes back to the US market in 1973 with small fuel-efficient cars, compacts, micro-compacts, subcompacts, sort of invited in by the rising price of gasoline. And again, to sort of give you a qualification on this, at first the car was appealing because it needed far less fuel than what was on the market. But people came to a quick realization. It was incredibly reliable. And to give you a visualization on this, up to 1973, in the morning, you knew where your neighbor parked his or her car the night before by all the fluids that had stayed in the driveway. They were leaking out. If someone owned a Toyota Celica, you had no idea where they had parked because it was all clean. And so here's what happened. In 1973, Toyota reestablishes the competitive bar in that sector because showing up with a car that they can make with twice the productivity, it's wickedly affordable. With a car that doesn't leak all over your driveway, it's also wicked easy to maintain and service, and it proves to be a much more affordable, reliable car than what's on the market. Now, that value proposition of affordable reliability, Toyota added to, because they started showing up with not only small cars, but mid-sized cars. Now, again, the world standard to do a major model upgrade on a car, it's a big deal, actually, because you have to redesign the car, so that's thousands of engineering years worth of work, retrain the workforce, re-equip the workforce, redesign your supply network. It's a big deal. So the world standard for such a thing was 4 years. And Toyota proved that at half the cost, you can do it in half the time. Their world standard was 2 years. Now, that has a devastating impact on everybody else, because now Toyota is not only selling a car which is more affordable, more reliable, but it's fresher too. And you start thinking about the products you buy and the difference in perception of something which is cycling through and updating on a 2-year cycle versus 4. I mean, 4 is like, for my kids, like 4, what was that? Like what Abraham Lincoln used? Anyway, there was that changing the game. And then the other piece was, in the late 80s, 90s, when Toyota decided that they needed to be a U.S. manufacturer of cars for the U.S. market versus an exporter from Japan, they proved that you could introduce new plants and train up workforces at a pace no one else can match. Now, it sort of begs the question, how does Toyota go from the Toyopet in 1957, which they were really pathetic at making, to this dominance on terms of affordability, reliability, time to market, etc. by the mid-80s, early 1990s. And the starting point for the Toyota folks was something like this, which is, why the hell are we selling a Toyopet in the first place? And some other guy says, because we don't know how to make a better car. Right? If we knew how to make a better car, we would sell it. This is the best we can do. And similarly, when someone asks the question, well, why does it take us 8 guys to do the labor of 1 elsewhere in the world? They say, because we don't know any better. If we knew better, maybe we'd have 7 or 6 or 5. We certainly wouldn't invest the input of 8 where 1 must be enough. So Toyota gets into this mindset that whatever they're doing, they very, very aggressively have to seek out problems in what they're doing. And wild aggressiveness. I mean, me on a box of donuts after a fast. I mean, that kind of aggressiveness. And then they say when you're on a problem, rather than recognize it and cope, be heroic, firefight, etc., do as much as you can to understand the problem, at least its causes, and do something to try and solve the problem. And then, this is kind of an interesting point, right? Because the conventional view of people turning wrenches in factories, that they were there to turn wrenches, and that you measured that person by how many wrenches they could turn, how many nuts they could drive, how big were their guns to do all that wrench turning. But in the Toyota case, they're saying, wait a second, if we're starting ignorant about what we're doing, And someone has arrived to see that we have a problem which we didn't really understand or well articulate, and they have insight into this. All of a sudden, they're the world expert on this situation, right? And you start thinking about that. It sounds like highfalutin to say, but the reality is, if you had that situation which no one else had been able to resolve, and someone comes over to that situation, comes to an understanding meaningful enough that they can make some kind of positive impression on it, they're the expert and the rest of us aren't. So they say, well, then what we have to do is build in as committed time into people's activity, not only seeing problems and solving problems, but sharing what they've learned. And so anyway, taking this one step further, because as I prefaced, knowing how to get smarter, better, faster matters a lot. It depends on finding fault, but it's a little bit hard to do that because we're psychologically, socially not well equipped to say, oh, hey, look at how badly I suck, right? There's a whole element here that if you're going to build your competitive presence on your dynamic of seeing and solving problems and spreading what's learned, then what you really have to make sure is that this whole thing is buttressed by leadership, which is constantly modeling, coaching, enabling this finding of fault. So anyway, what's the result of that kind of behavior? So as we said, our starting point was the Toyopet, an absolutely abysmal car made in an absolutely abysmal fashion. By the time Toyota gets to the mid-1990s, they have products, not just one, they have products in every significant category in the domestic automotive market, ranked 1 or 2. Now, just to give you some sense of things, when we think of automobiles, automation, that sort of, you think back to Ford. Now, if I read correctly, Ford a few months ago decided that they can't make money with cars. They're going to concentrate on trucks and SUVs and minivans and that kind of thing. And they're like, well, the cars will leave for somebody else. So anyway, that's one example. I want to give you one more example of how knowing how to get better, smarter, faster, knowing how to get to the right answer quicker. And again, that's not one of these like, Harvard Business Review, well, what you have to do is be first to market. No, you have to be first to market with the right answer. Being first to market with the wrong answer, I mean, that's just like stupid, right? So an example, the world auto market, that's you and me, sent the same signal to the world automakers, which we wanted double the fuel efficiency. And everyone, there's a sort of a nice side story, but Gene said I don't have that much time, so we'll park that for later. But there's a side story on how everyone tried the same approach to tinkering around the edges with existing architectures, more aerodynamic, plastic and aluminum to reduce the weight, electronic controls on the engines to get better combustion. And while all of that helped incrementally, it didn't solve for twice the fuel efficiency. So everyone went back to the drawing board for round 2, having gotten the answer wrong the first time. And they came up with the idea of a hybrid. And again, we can have separately over beer, like the nerd excitement over how cool a hybrid is. But it is a cool product. And so the idea of taking an electric motor, which is wicked good for acceleration, couple it with an internal combustion engine, which is wicked good at steady state, put those two together, throw a whole mess of software on top to coordinate them, you can get double the fuel efficiency. So Chevy's expression of that is the Volt. Toyota's expression of that was the Prius. But again, this gets back to knowing how to get to the right answer faster. Toyota showed up with the Prius with a 10-year head start on the Chevy Volt. And with a 10-year head start, not only have they put that technology through 6 and 7 and maybe 8 cycles now of modification and improvement, they've diversified its application. So it first came out on the Prius with a value proposition of a very, statement-making green product. But then they moved it on to the Camry with a value proposition to taxi fleets. Look, fill up your tank once a day instead of twice. Basically pay in fuel savings, you pay for the car in the first year. All right, then they started putting it on the Lexus, where it wasn't so much the savings in gas cost, it was the performance. So anyway, Toyota's taken their hybrid drive, because they had a 10-year head start, put it on 24 different platforms. And in the years since the Chevy Volt and the Prius came to market, the Chevy Volt has had about 100,000 units sold, and Toyota with its hybrid system has had 9 million units sold. Again, folks, it was the same flipping problem. And the difference in results is 90-1. I mean, if some of my students came in like that, I'd either say, damn, we'll just give you the Nobel now, or you're cheating. It's one or the other. All right, so this is not just an auto phenomenon. And again, there's countless others. Just to illustrate with one other, pharmaceuticals is another crazy industry where you invest billions of dollars over a decade to try to get to market with a product. They have this crazy system that when they have the puff of an idea, what you all might call vaporware, they file a patent. And that's great. You can tell them, Mom, hey, Mom, guess what? I filed a patent, right? And your mother's like, oh, I knew you were going to be a great biologist. But it would have been nice if he'd gone to medical school, become a doctor, but I'm okay with the biologist, right? But you file a patent then, but the problem is the clock starts ticking. And when the clock stops ticking, your revenues go to zero, because someone's going to make it the generic version. And we did a calculation that if you could get to market with a pharmaceutical every day earlier, it's $3 million. It's crazy, right? Right answer faster. And the other thing I just want to point out is in their market, if you're in the market with a therapeutic first, you get about 50% of the revenue that therapeutic will ever yield. If you're second, you're at about 25%. If you're third, you're about 15%. And if you're fourth, fifth, or sixth, it was a waste of time and a huge burn of money. All right, so anyway, all of this to the point of getting to the right answer fastest matters a lot. One last example, and this ties into the leadership. So this is a picture of Hyman Rickover, known as the father of the nuclear navy. And if you really have to dig into how he managed the creation of atomic power, all right, now you have to think about when he started this in the late 1940s, no one really had controlled atomic power. They had explosive atomic power, but not controlled atomic power. That required the invention of new science, the invention of new materials, the invention of new processes, et cetera, et cetera, et cetera. There's a lot of invention going on. And this was spread across not only the Navy, uniformed and civilian, but a contractor workforce which ran easily into the tens of thousands. And you ask, how did Rickover accomplish this? Well, he ran an organization which was based on the same learning dynamic. Design whatever you're doing so you can see what's stupid about what you're doing. That's Rickover's language. He's kind of a crass guy. Find out what you're doing wrong. When you see you're doing something wrong, find out immediately, as best as you can, why you're having that problem. And whatever you've learned from that experience, it could just be that the problem exists. It could be how to resolve the problem. Make sure you tell somebody else. That's the multiplier effect. And there's a whole... product placement, right? So in the bottom left hand of my slide is a bit.ly link. So if you want to read the Rickover case in more detail, you can download it there. All right, anyway, back to our programming. Rickover, no, seriously, I'm blowing through a 60-year career I'm doing in 3 minutes. It's not fair. All right. So anyway, there's a lot of detail about how you lead in that environment which has a lot of status and hierarchy in it, so that you get people to act actively, aggressively, there was a mention of safety before, safely, seek and call out problems, solve them, and share what's learned. Now here's the result of running an organization that way. The U.S. put to sea the first nuclear-powered submarine in 1955. Since then, across all the different generations of attack submarines and ballistic missile submarines, all the different crews which have sailored on them, all the different shipyards which have built and maintained them, the U.S. Navy's record on safety related to submarines and reactors is perfect. Since 1955, there's been no injury due to reactor failure on a U.S. submarine or aircraft carrier, for that matter. No injury and no environmental damage. Now, all right, now I'm just going to step back here for a second, right? This is Rickover's dynamic of, hey, if you've got a problem, call it out loudly. If it's called out, we're obliged to try and solve it. And if we solve it, we got to teach somebody. Now, who's the competitor for Rickover in the Navy in the 1950s? Yes, the Soviet Union. And let's just say we can assume their dynamic was not this. Yo, Comrade Stalin, I got an issue to raise with you. All right, so what's the result of trying to develop nuclear power in an environment where you can't even raise your hand? It's this. This is the curse. And the thing is, I could have filled up this slide with failed submarines from the Soviet Navy. Now, yes, well, what was the difference? It's the same basic science, right? The universe has laws, and they were trying to harness the same laws. They're trying to develop the same materials, the same processes, etc. So what was the difference? Was this. I got a problem. One side, this was okay. The other side, well, nah, everything's fine, comrade. So anyway, huge difference in performance if you can get this learning dynamic. Now, I'll blow through this example real quick. As Gene mentioned, I was inspired around some of these ideas by doing this Karate Kid immersion at Toyota, trying to stand up a first-tier supplier factory. And what really got impressed upon me was the absolute profound commitment, aggressive, energetic commitment to making sure that no matter what you were doing in an operating setting, you could see things going wrong. And that's like the entire third chapter of my book and elsewhere is about failures in operation that get ignored. They may be seen, but they're not swarmed and solved, snowballing to catastrophic effects. So there's one example of a nurse who gets confused in a fairly normal fashion between a vial of heparin and a vial of insulin. Same touch, same feel, same size, small type. But it's just the right set of circumstances because these confusions hadn't been identified and resolved, that those same confusions cause someone to confuse one for the other and cause patient harm. And it's a similar thing. NASA's experience both with the Challenger and the Columbia, when you do kind of root causes to why they suffered those catastrophes, the answer in both cases is that there were known problems, but the known problems were frequent enough, small enough to be kind of waved away, normalized, and dismissed until the moment that they congealed in a fairly fatal way. Anyway, won't spend any more time on this part. Worried about it for 15 years. It's in the book. Knock yourself out. But here's another example. June 4th, 1942, the Japanese Navy show up at the island of Midway in the Pacific. They show up with twice the aircraft carrier with which the United States Navy shows up. They show up with twice the pilots, twice the planes, twice the, etc. Double everything. Now, given that, who should have won the Battle of Midway? The Japanese, right? They show up with twice of everything. All right, well, of course, it didn't end that way. It ended that the United States won the Battle of Midway. It was a catastrophic defeat for the Japanese Navy. And because of that catastrophic defeat, it really impacted their ability to wage war in the Pacific for the remainder of the Second World War. So anyway, the reason I put this book cover on the left, the folks who wrote that book had access to Japanese archives. So they didn't write the battle from the U.S. perspective. They wrote it from the Japanese perspective. The book runs like 600 pages. I mean, it's so big that to read it, I wanted to carry it on trips and stuff. I cut it down the middle because it was too heavy. And you know how when you put your bags through screen, it wouldn't go through the hole. I mean, so I cut it. I mean, it's a big book. So I cut the book in half, and I'm reading through this whole thing. And the authors are magnificent. They give you almost like minute by minute, man by man account of what's going on. This particular pilot, as he turned his plane into a bank, this is what it would have said on his instrumentation. It's at that level of detail. So you make it all the way through the end of the book, and then there's this last chapter. And it starts with kind of like my words, but clearly their intent. The authors say, "Dear reader, you've just read our 600-page book. Congratulations." Now, after reading this gigantic book, when do you suppose the Japanese lost the Battle of Midway? So I'm thinking, that's a trick question, right? Because I've seen the movies from Hollywood, and in Hollywood it's 3 o'clock in the afternoon. Because at 3 o'clock, maybe 4 o'clock in the afternoon, there's some very handsome American aviator. He's got that, square jaw and a scarf and whatnot. And at 3 o'clock in the afternoon, he turns his plane, he comes diving in, and he releases his ammunition right exactly in a place to cause a huge explosion, and the Americans win. But I'm saying, well, this is a 600-page book, not a movie. So I start flipping through knowing the answer can't be 3 o'clock in the afternoon. So I'm going back and I'm thinking to myself, well, maybe it's in the morning. Maybe something happened 10 o'clock in the morning. But I'm not nearly the front of the book yet. So I keep going and going. And I find a spot, late May. The Japanese Navy has some of its ships late to deploy out of the harbors around Tokyo. And so that's it. These guys didn't get to where they needed to be on time. So I'm thinking, all right, I gotcha. Late May, that's when the Japanese Navy lost the Battle of Midway. Flip the page, and the authors say, dear reader, you're probably thinking late May. The answer is the Japanese Navy lost the Battle of Midway no later than 1929. I'm like, 1929, I'm at the table of contents. There's no 1929 in here. You're screwing with me, right? So then I keep reading, and they say, well, here's the deal. By 1929, the Japanese Admiralty had locked in their assumptions on how war would be fought at sea. They had drawn a whole bunch of lessons off of the 1905 encounter with the Russians. And based on those assumptions that the entire fleet of one nation would meet the entire fleet of another nation, they'd meet head on, one inflicting devastating impact on the other, and the one that got devastatingly impacted, its nation would lose the will to fight. In 1929, they locked in as that was their doctrine. And everything else was built off of that one assumption about how navies would collide on the high seas. And so how they designed their aircraft carriers, how they designed their aircraft, how they designed fueling, arming, launching, recovery, training, tactics, etc., all came off of that. Now here's the thing. Once they locked in on that assumption by 1929, they left it unchallenged. And the book concludes with a description that for Midway, not surprisingly, the Japanese admirals had a battle plan. And so going into the Battle of Midway, they said, what we need to do is run a war game to rehearse. Stick on that word for to rehearse our battle plan. So here's what they do. They set up a giant table, like big, huge ping pong table or boardroom table, probably boardroom table, and they're over here in all their admiral finery. And way down here, they got some junior officer schmo. And over there, their job is to fight the Japanese side, and over here, his job is to fight the U.S. side. So they take a stick and they shove a little piece of a little wooden ship forward, and he takes his turn. They're back and forth. And after a few moves, the referee, throws a flag, blows the whistle. Now, ostensibly, it's because the junior officer is not fighting according to the battle plan. What's the real reason? He's kicking butt. So what do they do? Well, what should they do at that point? They should stop, right? Because if that schmo can, right? But what do they do instead? They say, well, he's a moron. He doesn't understand the battle plan. Let's get another guy. So they got another, schmo junior officer. Well, he does the same thing. He looks down the table. He looks at the book, down the table, look at the book. He says, you got to be out of your flipping mind to fight this way. They got twice everything. So he moves this way and that way, not that way. There's another whistle. And the way the book ends, you get the sense that they've gone through junior officers, they've gone through petty officers, they've gone through their sailor recruits, and they're just getting noodle vendors off the street to stand over here. But they keep losing. Now, from my perspective, I think that's a very good thing. But what's the real cause of loss is that they got it in their head that they weren't going to seek out problems. And I went through the word quickly. They were using the war game to rehearse the battle plan, when they could have been using the war game to stress test the battle plan. But they didn't. They didn't stress test it. They did. They just ignored it, I guess, right? They didn't use the war game to stress test. They used it to rehearse. And because they didn't at that moment find the bugs in their plan, the fault in their thinking, they didn't correct the fault in their thinking, and that fault in their thinking became fault in their doing. And the good guys win. All right, so what they did is the exact opposite of what Toyota did. They did the exact opposite of what Hyman Rickover did. They didn't seek problems. They didn't solve problems. They didn't spread learning. And why was that? Pathological leaders. So anyway, I got about a minute left. Here's the other thing I just want to offer to you. I'll give the example. If I run over a minute, Gene can sue me. Quick example. Let's go with the positive one. Email me for the negative one, all right? I'll send you the paper this is in. All right, the positive one. So 61, President Kennedy says, we're going to send a man to the moon by the end of the decade, return him safe to the earth. And they do that, right? There's a lot of drama. If you haven't seen it, check out the movie First Man. Because when Neil Armstrong and his crewmate are getting ready to land on the moon, they discover that NASA's picked sort of a cruddy landing spot. And the way the story goes, something like with 30 seconds of fuel left, they turn off the autopilot, manually fly the lunar excursion module to a safer place, and when they land with about 8 seconds of margin of error left. And you go like, damn, heroes, how'd they improvise, literally, figuratively, on the fly like that to figure out what to do with 30 seconds left to go? The answer is they didn't improvise at all. And so the picture in the bottom right, that spiderly-legged contraption, was the Earth version of this lunar excursion module in which, a flight simulator, in which the astronauts practiced all sorts of screw-up scenarios. Now the reason I bring that up, our natural inclination is to prepare, to practice, to rehearse for the situation we expect, what we consider normal. What we don't do is typically what we don't do is gain competency in the outliers. And if we don't gain competency in the outliers, again, ask me for the article, we get results like this rather than heroic results like this. So anyway, just to finish up here, my slides will be up on the website, but there's a set of actions you all can take. For example, during planning, when you have a plan or a code, whatever it is, do you show it to your colleagues and advocate for it and say, oh, well, let me tell you, here's my plan, here's my code, here's my design. Let me tell you all the good things about it. Or do you stand up and say, here's the best I could do, now tell me what's wrong? All right, now that's uncomfortable, but that's necessary. Similarly, if you supervise other people, when they put something up, do you say, oh, that was nice, da-da-da-da, or do you help them discover the faults? That's the planning side. And then, anyway, so here's what you can do in terms of your just basic habits of the day. When you go up to somebody, you say, hey, how's it going? What are you doing? Their inclination will be, hey, everything's going fine. And your question has to be, what's not working? Not because you're not doing wrong, but what's wrong with the situation we've created for you that's not working? And then ask the question next, well, why isn't it working? What's your understanding? You're the person who's got the most tactile sense of it not working and why. What can we learn from that? What can we change and what can we teach? All right, anyway, that's my slides. Gene asked me, he said, Steve, you're last in the day, you can do a little what you're up to now, what's new. And also all right, so we'll get through these guys in a paper, send me an email. In terms of what's new is that we've, over 15, 20 years now, have been wildly, aggressively advocating for this dynamic of seeking problems so that they can be solved. And in the seeking, the identification, the investigation, and the solving, something can be learned both individually and collectively. What we've discovered is that this is wicked hard to do in large organizations with a workforce that's dispersed. and a workforce which is mobile. Nurses in hospitals think about mechanics and technicians at an airfield, so on and so forth. So anyway, we've created a little piece of technology. See, I want to fit in with y'all guys because the bow tie's not doing it, so I want to have a tech angle. So we created a piece of software to solve for the problem that the person with the problem can't tell anybody in an effective, efficient fashion, so they kind of sweep the problem under the rug until it explodes on them or someone else. And so the format of this is that we've put on mobile devices it's sort of a portable and-on cord for the lean people in the room, portable and-on cord. 3, 5, 10 seconds, boom, I've got a problem. That becomes a ticket to someone who owns that type of problem to come and help in here, right? And
so, Stephen, what is the help you're looking for?
All right, so anyway, so here's the help I'm looking for. 10 more seconds.
8, 7.
All right, so here's what we're looking for. We're looking for the fourth guy. We got 3 guys now. A lot of this grows out of my own work and interaction with folks. We've got a guy who's really good at getting users set up. We got another guy, let's just say he has a perfect personality for the technical side of things. What we need is the fourth person who can, when we have a lead, develop that into a real possibility. And if there's anyone in the room who might want to be a user, let us know too.
Thank you.